The topic of my presentation is libsearch, normal EI search for spectra sent from Chromatogram window. It includes both a video and a handout, and the handout could contain certain topics not discussed in the video. See the full course on my website for the NIST 26 with integrated deconvolution library searching for both EI GCMS and LC-MS-MS. There's lots of previous information on libsearch and other NIST software on my website. This video only discusses the program basics, so if you want to learn more, check out the videos and the associated handouts, plus many webinar resources that are found on my website. The main reasons for sending results from the chromatogram to the libsearch window are the EI normal identity search results in chromatogram only shows the best result, only one hit per unknown. The same search in libsearch shows a large list of candidates, so you'll often find some additional information that might help you identify the unknown, especially if you have any doubt about the primary one determined in the chromatogram window. So to do this, you select the entry that you want and then send it to the library search. And you can see here we had the one entry here for the unknown, the identification, but over here for that same unknown we show many. So let's show that in the software. So let's select one from the bottom, which is what it thought was dodecane. It shows up as a green dot for this peak here. Right click, library search. Let's just make sure we have the settings set up properly. So we'll go up to here and we're doing an EI identity normal search, which is the same we did in the chromatogram window, except we'll get more hits here. And we'll make sure it's a full spectrum search, not a partial spectrum. The default pre-search. The libraries, we're using the main lib and rep lib, but you could use the Wiley and other user libraries to get a combined results for all of the libraries. And also I have automation set for automatic search on. So, okay, so let's do the search again. I'll hit go to repeat the search with these settings. And I get the same things. It was already set up. So you can see if we want to step through these, I left click on the first one in the bottom hit list. And I use the arrows on the keyboard to step through the hits. You notice there's a lot for dodecane because there are multiple library spectra for this component. If you look up at the top, we had 100 spectra, but if we want to reduce the duplicates, come down to where it says best matching only. You can see it drop from 100 to 60 and no longer have the duplicates for dodecane and others. The other things you'll notice about the window are it shows the type of the search you performed at the bottom here, EI normal, and the displayed format is EI normal also. At the top is the unknown, the bottom is whatever one you have selected from the list from the possible identifications, and in the middle is a butterfly plot with the unknown on the top and the known on the bottom. So it makes it very easy to review the data. There are other options that one can use besides just the standard full spectrum search to get the score. The full spectrum matching compares the entire spectrum and works best for clean data. Reverse matching focuses on whether key library peaks are present, making it robust to chemical noise. So if you had a mixture. In other words, reverse dot search does not penalize for extra peaks in the spectrum that are not present in the library spectrum. Another use of the reverse type search is the Wiley library entries. The Wiley library contains many partial spectra from the literature, which can be useful, and thus the reverse search, the impurity tolerant search, reverse dot, gives better search results against an unknown pure spectrum against these partial library reference spectra. You can always sort the results that you got initially by clicking on reverse match, but the problem will be some of the best hits for the reverse match could be filtered out when you do the pre-search. So it's better to specify the method before the pre-search. The pre-search is employed to greatly increase the speed of the overall search because it finds candidates quickly and then takes that candidate list and carefully searches it to get the final search results. It also has, you can see up in here, it has a partial spectrum search, PSS dot, and that's used mainly for tandem applications. So let's demonstrate that in the software. So if we wanted to search this by a reverse search here, we would need to change the settings if you wanted to get the best results. But of course, like I said, you could just go down here instead of clicking on match to sort, you can click on it for reverse match and it'll be the highest and it'll be sorted by the list here. But the only problem is if it doesn't come in through the pre-search, you might take out a reverse match that would be useful to you. So it's best to go in to the search settings here and go to search and change to partial search, which is this impurity tolerant search, reverse dot, and then say OK, and then do the search again. And when you do that, you'll see that the results come in and are sorted by reverse match instead of match, which is the normal way we do it. But you can also switch here to go back and forth. But this is a reverse search. And you can see at the bottom, it told us the type of search. It was an EI normal, and the displayed is EI normal. But note here, there was nothing here before when it did the normal search where it's sorted by score. But when it sorts by reverse search scores, you'll see the REV in the bottom of the screen here. So that's pretty much the basics of using the chromatogram entries to send over to the lib search to get further information. I hope you find it useful. Good day.